So this question is about the chemical kinetics. So the first one is to determine the rate law. So let's write the general rate law as rate equals K over times the concentration of C2H4Br to multiply the X to the power of X, multiply the concentration of iodide to the power of 1. So we're going to try and determine what is the X, what is the Y, and what is the K values. We have 3 sets of data. So if you look these 3 sets of data and plugging this data into this general rate law, we're going to see for the first one, we have and 0.127 and 0.102 are the initial concentrations, and X and Y again are the orders we need to determine. And again, right here, K is a rate constant. I can do the same thing for experiment 2. So again, these are the initial concentrations. We just plug in, and we will be able to write these 3 equations. So this is the rate and rate constant, concentration, and also the concentration of iodide. So now to solve this one, we're going to do something very special right here. So first, we're going to divide up equation 2 over equation 1. And you will see on the left side, so it will be 17.4 times 10 to the power of -5 divided by 6.45 times 10 to the power -5. And on the right side, okay, on the right side, when we divide 2 by 1, we cancel this. We also cancel this. So what we left right here will be 0.343 to the power of 0, or divided by 0.127 to the power of X. Okay. So if we do a little bit calculation right here, on the left side will be 2.70, and on the right side is also 2.70 to the power of X. So clearly X equals 1. Okay. So we can do the same thing for equation 3 divided by equation 2. Okay. So what we have on the, see right here, so these 2 right here, so this one, so 12.6 divided by 17.4, so we're going to write here 12.6 divided by 17.4 times 10 to the power of -5. On the right side, we will be able to cancel this. And remember, this is just the 1 right here. So basically is the 0.203 divided by 0.341. So that will be 0.592. And next one right here is divided by these two. Okay, so 0.125 divided by 0.102, that will give you one. Well, I'm going to write here. It will be 1.225 to the power of y. Okay. So if I rewrite this a little bit, so that it will give you 1.22, which is on the left side, 5, equals to, on the left side is, well, if you do a calculation on the left side, it will be 0.724 equals to 0.592 and 1.225 to the power of y. So which means if you divide 0.592 on both sides, so that will give you 1.225 equals 1.225 to the power of y. So from here, we will be able to determine y cleared equals 1. So the Reed law will be K multiply the concentration of the first product to the power of 1 and concentration of the second reactant to the power of 1. So that will be the Reed laws. So the next question is, what is the Reed constant? So we can use any set of data experiment to determine this. I'm going to plug in the concentration of the experiment 1, and we can determine what is the rate. So the first one, the reaction rate is 6.45 times 10 to the power of -5, so equals K, and the concentration is 0.127 for the first one and 0.102 for the second one. So you solve this, K will be 6.45 divided by 0.127 and 0.102. So that will give you the K constant at 4.97 times 10 to the power of -2. Okay, so that is the K constant, which is the Reed constant K. Okay, so the next part is, what is the rate of what is the rate in terms of triiodide? So keep in mind what we put in the Reed laws, that rate is the rate of the reaction. So rate of the reaction in terms of the triiodide will be delta triiodide over the delta T, okay, and also multiply 1 over 1, okay, because the if you look at the reaction, the balanced equations, the coefficient for triiodide is just 1. So we put a 1 right here. So basically it's the same. So which means the rate in terms of triiodide is equal to the rate of the reaction, and that will be 1.10 times 10 to the power of -3. Okay. Well, the rate, okay, actually the rate right here, that is Okay, you can plug in the rate constant and concentration, you will get this number. And D right here, what is the rate in terms of the iodide. So rate right here will be negative delta iodide delta T multiply 1/3, and therefore the reaction rate in terms of iodide will be 3 times the reaction rate. Reaction rate right here, I did not include the calculation, but reaction rate you can calculate actually by using the given concentration. So remember, as I said, the rate equals K, so it will be 4.97 times negative 2 times the concentration of both reactants, and both reactants they have a concentration of 1.5. So if you plug in right here, it will be 1.10 times 10 to the power of 3 m/3. So that's the reason why I get these numbers. Okay, I did not include it right here, but it should be very easy to determine these. Then if plug in this concentration, right, this number here will be 3.30 times 10 to the power of -3. Okay, so to answer C and D, you need to determine the reaction rate first using the concentration and rate constant. Then you're going to determine what is the rate in terms of the iodide and or triiodide, which you have to consider the coefficient. Okay,